Alright folks, day 1, unit 2 video notes. We're going to be talking about quadratic functions. First off, we want to write the equation of each graph. Now, I don't care if you write them in factored form or vertex form or standard form of a polynomial. It's totally up to you. And the ease of it kind of depends on the problem. So let's look at A real quick. Notice that we have y, and by y I mean x-intercepts happening at x equals 1/2 and at x equals negative 2.5. I don't know why I wrote 1 as a decimal and 1 as a fraction. I could write 5/2 for that as well. But let's figure out our scale, see if we have a dilation in here. If I go over 1 from my vertex, I should be going up 1. Am I? I am, so that tells me that a is 1, because 1 squared is 1. So this function is going to be y equals x minus 1/2 times x plus 5/2. Yay! It's probably, in fact, even a little bit easier to just go into vertex form and say that y equals x plus 1 squared minus 2 because of the vertex point they give us right there. So that's what I'm going to do here with this equation. This is going to be y equals x squared minus 2. Whoa, wait, weird. Okay, there we are. Minus 2 for the same reasons. Again, you could check and make sure your a value is in fact 1, but it is and we're good. So really we're just thinking about transforming the x squared mother function. So this one, notice it's flipped, but again, my scale is going to give me an a value of 1, but negative 1 this time. So I'm going to get y equals negative x minus 3, boop, squared minus 2. Cruising through these, again, check out your a value, make sure it's good. It is once again good. It's also once again negative. So I'm going to get y equals negative parentheses x minus 2 squared plus 4. Sweet. Making quick work of these silly little graphs. Finally, this one again, is my a value good? Yes, it is. Y equals x plus 4 squared. Again, plus 4 shifts it to the left 4. This one, I'm not even going to talk, I'm just going to do it. Wait, that's impossible for me, so I will talk. Negative x minus 4 squared, like that. And finally, this not last one, but this penultimate one, y equals a value, again, is still 1, so y equals x minus 2 quantity squared. And finally, the last one, y equals negative, because it is flipped upside down, and my a value, again, is 1. It's going to be negative. I don't actually need parentheses there. It's going to be negative x squared plus 3. Sweet. So that's all of them right there. There you have it. Let's move forward into today's lesson. But that was probably like a well-needed warm-up memory of what you did last year and what you actually did last unit as well. Alright, so today we're looking at factoring quadratic functions, so writing them as a product of two linear factors like that, something. Finding solutions to quadratic equations, which we could then say x equals a is a solution and x equals b is a solution if we have it in factored form like that. We're going to take a brief look at the quadratic formula, but mostly not. We're going to look at that more when we talk about complex numbers and imaginary numbers. And we're going to complete the square, which is writing a function in vertex form, going from some other form to vertex form. So let's jump into it. We want to find the zeros and the coordinates of the vertex for this function. So to find the zeros, we need to factor it. We're playing the factoring game. We're saying what two numbers a times b that equals negative 8 also fits the description of a plus b equals negative 2. Notice the negative 8 from there and the negative 2 right there. They have to add to give you the coefficient on your x term, and they have to multiply to give you your constant term, negative 8. Well, if you think briefly for a moment, 4 times 2 is 8, so it's a good idea to start listing factors of that constant term. 4 times 2 is 8. One of them needs to be negative, one of them needs to be positive, and negative 4 will do it for me because negative 4 times 2 is negative 8, and negative 4 plus 2 is negative 2. So I can factor f of x as x minus 4, x plus 2. And that tells me that my zeros will occur when x is equal to positive 4 and when x is equal to negative 2. So now I want to complete this square on this. So, how do you do that? How do you complete the square? Well, we have x squared minus 2x minus 8, and I'm going to do it my way, because it's my way or not the highway, unless the highway is your way. I don't know, go some other way, figure it out. But this is what I've been doing recently. Since I know that my coefficient right there is negative 2, first off notice that my coefficient on x squared is just 1. That's good, that's what I want. If it's not, you're going to have to factor stuff out first. But since it's x squared, look at that middle term, negative 2. Take half of that term. And so that tells me I'm going to end up eventually with this factor x minus 1 squared. And again, that 2, I just divided that by 2 to get that minus 1. And now I'm going to ask myself, well, what is x minus 1 quantity squared? Well, it's going to give me x squared minus 2x. Negative 1 times a negative 1 is a positive 1. And now I'm going to compare this back to my original equation. My original equation has a constant term of negative 8. This has a constant term of positive 1. To get from positive 1 to negative 8, you have to subtract 9. So my completely vertex-formed equation is going to be x minus 1 quantity squared minus 9. And you can see, if I then simplify this side out, that it does indeed give me the same equation that I started with. So, again, the whole point of vertex form is I can look at this and say, okay, well then my vertex will occur when x is positive 1 and y is negative 9. Sweet, so I believe I'm done. Check yourself graphically. We could even sketch this graph real quick because I have x-intercepts at 1, 2, 3, 4, and 1, 2, and my vertex is at x value positive 1 and 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm right there, going up like that. Where's my y-intercept going to occur? Oh, negative 8, because your constant term is your y-intercept, so I'm going to get that point right there. And I got myself a pretty decent looking graph without too much work. So that's pretty much all we're doing in this lesson today. Again, vertex form is useful because the vertex is the point h, comma k. Yep. Remember we talked about that. Alright guys, so I basically just talked for like 15 minutes without realizing that I hadn't hit the record button, so I get to do it all over again. Hooray! So, I believe I was leaving off, make note, I'm going to call this vertex form. Your book is going to call it standard form of a quadratic function. Just know that they're the same thing. So let's go ahead and now look at what I call the box method. So you can actually draw yourself a little multiplication grid here. And we want to complete the square on x squared plus 8x plus 11. So I'm going to set up my box like this with an x and an x up there. And then I'm going to be adding 4 to both of those because of that 8x right there. Because if I go through and multiply each term, x times x is x squared, x times 4 is 4x, and 4 times x is 4x. In the end, I'm going to add all of these boxes together. So I'm going to get 4x plus 4x gives me that original 8x. So since there are 2 of those boxes, I have to divide it by 2. Now, finally, 4 times 4 is 16, and that represents the quantity that I had to add to x squared plus 8x to complete the square. So, if I still have my plus 11 there as well, I can't change the value of this function by 16, so since I added 16, I also have to subtract 16, and then I can write my answer as x plus 4, quantity squared, again squared there because that is the same expression right there on both sides of that box. where am I going? There am I going. Okay, and then I can simplify this. That's all in my square. 11 minus 16 is minus 5, and that is what y is equal to. Sweet. Let's do another one. What if you have a coefficient out front that's not just a positive 1? Well, factor it out. So factor out that negative. You get x squared plus 4x. And I'm going to close my parentheses off. I'm going to leave my constant term as it is, because this is the point where I'm looking inside. I see I have a 4x term there, so I'm thinking x plus 2 quantity squared. But I do have to take that negative along for the ride. But let's think about what that is. Well, if I simplify the inside, I'm going to get x squared plus 4x plus 4. And so then if I distribute that negative in, I get negative x squared minus 4x minus 4. And let's compare that to the original. First two terms are the same, negative x squared minus 4x. But there I have a constant term of 1, and here I have a constant term of negative 4. So to get from negative 4 to positive 1, I need to add 5 to both sides. And I get my function, my completed square. Negative quantity, x plus 2 squared, plus 5 is the same as f of x. If you add 5 to that, you will see that you get the same thing. Cool. This one is no different. Don't let it scare you. Just factor out that negative 4 to start, and you're left with x squared. 24 divided by negative 4 is negative 6x, and I'm leaving that 41 by itself for now. So notice the negative 6 is telling me that I'm going to need an x minus 3 squared. I need to leave that negative 4 there, and let's see what we have at this point. X squared minus 6x plus 9. Now let's distribute in that negative 4 to get negative 4x squared plus 24x. Notice that is the first two terms of my original function. And then 9 times negative 4 is negative 36. But I don't want negative 36, I want negative 41. So again, to get there, I need to subtract 5. I don't know why all these numbers ended up being plus or minus 5. It just happened. But that tells me my final completed square is negative 4 times the quantity x minus 3 quantity squared minus 5. And that is equal to f of x. Whew. Okay, that's a lot. Take a breath. So we want to write the equation of the parabola that goes through that vertex and also that point. This is a lot like the warm-up problem we did. We need to remember vertex form, which is y equals a times x minus h squared plus k. And at this point, we just need to do that hint, substitute into vertex form. Again, y is going to be the y value of that point, x is going to be the x value of that point, h is the x value of your vertex, and k is the y value of your vertex. So y is 2 equals a, I don't know what a is, that's what I'm trying to find, times the quantity x, which is 1, minus h, which is 3, squared, plus our k value, which is 4. So let's solve this equation for a. 2 minus 4 is negative 2, equals a times that whole thing. 1 minus 3 is, I believe, negative 2. Negative 2 squared is 4. So divide by 4 and we get a equals negative 1/2. So now all I have to do is rewrite this equation. Y equals negative 1/2 times x minus 3 squared plus 4. And that is my answer. But check this out. We can also identify the vertex of the quadratic function even if we don't want to really do much work. We can use this nifty expression, negative b over 2a, because negative b over 2a is equivalent to your h value. That is the x-coordinate of your vertex. And remember, we're talking about a, b, and c like that, just like with the quadratic formula. So substitute into negative b over 2a to find your h value. Well, b is 24, so negative b is negative 24 over 2 times our a value. Our a value is negative 4. So now let's go through and let's simplify. Sorry, the music was getting loud. It was picking up the beat. Let's just do this mentally. Negative 24 divided by negative 4 is 6. And I still have my over 2. 6 over 2 is 3. So that tells me that That is the x value of my vertex. But what's the y value? Well, substitute into our equation. Find f of 3. f3, so negative 4 times 3 squared plus 24 times 3 minus 41. And I'm not going to do all that. You can simplify it yourself. Lo and behold, when you simplify it, you get negative 5. We probably should have guessed that because apparently negative 5 is the number of the day. But sweet, that's cool. And if you want to know where that negative b over 2a actually comes from, well, it comes from completing the square on that standard form polynomial quadratic function. Let's just do it really quickly because it's cool. Factor out the a, you're going to be left with x squared plus bx over a, because think about it, a times bx over a is bx, close that off, get my plus c, and then let's complete the square, and whoa, messed that up. Let's complete the square, and our technique for that is to take x plus half of that term, and that term is bx over a, so half of it is bx over 2a, sweet, squared, and we still have our a out front. But let's do my technique before, like we've been saying. What does that equal? Well, need a times x squared plus, I'm going to get x times bx over 2a, which is going to be bx squared over 2a, plus another one of those, bx squared over 2a. What am I saying? And then I'm going to get bx over 2a. Wait, I'm sorry, I totally am lying to you about all of this. That should not be bx over 2a, that should be b over 2a. So that should not be bx squared over 2a, that should be bx over 2a, and that should be bx over 2a. You see what I'm saying? Because you just took the coefficient. My bad. So, anyways, that looks better now. And then if I do b over 2a quantity squared, I'm going to get plus b squared over 4a squared. Close that off. Let's simplify it and distribute in. So I'm going to get a x squared plus 2 bx over 2a's, so that's the same as bx over a plus b squared over 4a squared is what I have worked to so far. Now I want you to notice two things. First off, I want you to notice that I've rewritten the left side as a times the quantity x minus negative b over 2a, because normally we are looking at the form x minus h squared like that. So I wrote it as minus instead, so that you could see that the x should actually be happening at the value of negative b over 2a. That's pretty cool. That's where that came from on the last page. The negative b over 2a comes from this guy right there. That's sweet. Let's finish this up. Let's think about what our k value has to be then in terms of a, b, and c. So my last step is always comparing what I have to my original. Well, my original, I'm sorry, I just realized that I distributed the a into my x squared term, but I missed it there. So that should be a over a, which is going to give me just that negative bx term, which is what I wanted, the positive bx term, which is what I wanted. But notice now I've got this b squared over 4a squared instead of my c. So to get from b squared over 4a squared to c, I need to subtract b squared over 4a squared and add c. It's the simplest way to do it, so that I can finish this off as a times x minus negative b over 2a squared plus, minus b squared over 4a squared plus c. And if you take just that last expression there that I put in red, that should give you your k value, the y value of your vertex. So check me on this, see if that actually works. That'd be cool. So let's just super quickly talk about the quadratic formula, which gives us the solutions to a quadratic function. that is of the form negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, we're talking about our a value, our b value, and our c value. So substitute in, that's all it is. So x equals negative b. Well, b is negative 3, so negative b is positive 3, plus or minus the square root of b squared, which is going to be 9, minus 4a, which is negative 2, times c, which is 5, all of that over 2 times a, which is negative 2. And let's simplify, so we get 3 plus or minus the square root of, well, let's see what this is. 4 times negative 2 is negative 8. Negative 8 times 5 is negative 40. 9 minus negative 40 is the same as 9 plus 40, so we're really talking about the square root of 49. And again, that's all going to be over negative 4. So we're almost done now. 3 plus or minus the square root of 49. Well, that's giving me two separate equations. It's giving me 3 plus 7 over negative 4, and it's also giving me 3 minus 7 over negative 4. That's what that plus or minus means. You literally get two different equations there. So 3 plus 7 is 10. 10 over negative 4. Let's divide numerator and denominator by 2. We're going to get negative 5 halves. And let's go down here. 3 minus 7 is negative 4 over negative 4 is 1. So I found the two solutions. X equals negative 5 halves and x equals 1. Sweet! Last thing, let's sketch the graph of this function without using a calculator. And I want to show the vertex and the x-intercepts. So let's factor out that negative. Let's get negative x squared minus 2x minus 15. What are the factors of negative 15 that add to give me negative 2? Well, I can do that in my head pretty quickly. It's going to be a negative 5 and a positive 3, because negative 5 plus 3 is negative 2. So that factors as negative x minus 5 times x plus 3. So that tells me that my x-intercepts are going to happen when x is 5 and negative 3. And I can complete the square. So negative x squared minus 2x, keep that plus 15. I'm going to take half of that negative 2, so I'm going to get negative x minus 1 squared, which is the same as x squared minus 2x plus 1, but I'm going to be making the opposite of everything, so it's going to be minus 1 like that. Compare the negative 1 to the positive 15. How do you get there? Well, you have to add 16. So completed, I get negative x minus 1 squared plus 16 is equal to y. And I can graph this now. I'm told my vertex has to be at 1, 16. So I'm going to do a lazy graph here, but I'm going to get 1, and I'm going to get positive 16 up there. And my x-intercepts are at 5 and, what is it, negative 3. So there's that. And there's that. That second half was bad, but there we go. That looks kind of good.